Hi, have you ever wondered how can I analyze how fast a function grows? Well, look no further because me and my partner are here to help. This video will help you in learning everything you need on how function grows. My name is Chard Perez and my partner is Mamaril, and we're here to teach you about the growth of functions. In growth functions, we will learn how to compare two functions and compare the efficiency of different algorithms that solve the same problem. One of the important criteria in evaluating algorithm is the time it takes to complete a job. To have a meaningful comparison of algorithms, the estimate of computation time must be independent of the programming language, compiler, and computer used, must reflect on the size of the problem being solved, and must not depend on specific instances of the problem being solved. For example, take an algorithm for sequential search, where L is an array with n series, index 1 to n, and x is the key to be searched for in L. The largest number of execution of this comparison is n, which occurs when x is not in L or when x is at Ln, and the loop is executed n times. Let fg is equal to r is r. We say that f is big O of g if there are constants c and k, that all of x is greater than k, and the absolute value of f of x is less than or equal to c, and the absolute value of g of x. This is read as f is big O of g. Now, c and k are called witnesses to the relationship between f and g. One pair of witnesses are enough for f and g. Do note that often find this written as function of x is the big O of g of x, or the f of x is equal to the big O of g of x. This is not strictly true, because big O does not refer to the values, but to the function. So that means the equality will not hold. When spoken truly, the big O of g is the class of all function f that satisfy the condition above. The formally correct way to write it is f is an element of the big O of g. Now, let's go to another big topic, which is about the big omega. Let fg is equal to r is r. We say that f is big omega of g if there are constants c and k, such that all of x is greater than k, and the absolute value of f of x is greater than or equal to c and the absolute value of g of x. Like what I said earlier, this is read as f is big omega of g, and c and k are still the witnesses to the relationship between f and g. While big O gives an upper bound on the growth of a function, big omega gives a lower bound. It tells us that a function grows at least as fast as another. F is big omega of g if and only if g is big O of f. Now move on to the last big topic. It is called big data. Let fg is equal to r is r. We say that f is big data of g if f is big O of g and f is big omega of g. This is pronounced as f is big data of g, and also that f is order of g and f, or f and g are of the same order. F is big data of G if and only if there exists constant C sub 1, C sub 2, and K, such that C sub 1, G of x is less than f of x is less than C sub 2, G of x if x is greater than K. This follows from the definition of big O and big omega. Thanks for watching. I hope you learned something from us. Please subscribe and like our video. See you next time.